AI, 지능이 뭔지, 뭐라고 생각하는지 다들 한번 써보세요. 준열 학생이 brain이라고 썼어요. brain. 지능은 brain이다. 오늘은 가볍게 수업할 거니까, 네. 좀 써보세요. 지금 가뜩이나 얼굴도 안 보이고 소리도 하나도 안 들려서 되게 저도 벽 보고 이렇게 얘기하는 것 같아서 조금은 답답합니다. 열심히 좀 써주세요. 스스로 판단할 수 있는 능력, 또 판단할 수 있는 known something이 뭐야? 뭐 아는 거? known something. 인텔리전스 하면 떠오르는 거, decision making process. 되게 공부하는 그 스타일의 답변이 나왔네. decision, smart processing system. So have you ever heard about IQ test? Thinking, right? So people do the test, right? IQ test. Intelligence. What is the Q? Intelligent question? I don't know. Intelligent. 잠깐만요. IQ가 뭐였죠? 갑자기 기억이 생각해 보니까 IQ에 뭐가 약자인지 모르겠네요. IQ가 무슨 약자인지 아는 사람? IQ는 Intelligent Quotient이라고 하는 거군요. 네, 뭐 하여튼. So, yeah, you know that. 박태화. 역시 태화 씨, 태화 학생 이렇게 박학다식합니다. IQ 테스트도 있는데 여하튼 우리가 이제 그 intelligence라고 하는 것 때문에 관심이 많죠. We have and how do we measure intelligence, right? So we have some IQ tests or something like that for the people. And when you talk about intelligence, what is the key attributes? You already mentioned that, right? The processing or know something or decide something by itself. And decision-making process and thinking or something like that. Maybe we can say reasoning, right? 국어 시간에 이 reasoning 같은 거 많이 배웠죠. And decision, as Yagyong mentioned. And maybe you can classify something, right? This is kind of core and hot topics in machine learning, right? Everything has a category and you can classify them. And knowledge, as someone mentioned. And what about like kind of running? This could be another core attribute of intelligence, right? Not like kind of some other objects. Humans, they run something. That's why humans are intelligent, we say that. And something like that. And maybe we can think about some input-output function approximation. Yeah. Try to matching inputs and outputs. Yeah, that's kind of, the key attributes of intelligence and something like that. And I may ask you something. So what about, let's think about some objects. So we have a thermostat, right? In your room, there is a thermostat. So you can control the temperature in your room, right? And can you say there is some intelligence in it? What about air conditioner? In my room, there is a AC, and there's one mode, AI mode, or something like that. So should be having some intelligence in it. Anyway, so this kind of device, you can control something. You can give some actions, but maybe they are not that much. We're not saying that they are intelligent, right? But how about human? Surely there is no doubt, right? Anyone, if you ask someone, oh, what do you think, human is intelligent or not? And they surely answer that a human is intelligent. I think, and maybe you can agree that the most intelligent probably is human. So what is artificial intelligence? So a lot of people, they study about intelligence in computer science and psychology or cognitive science and some other area. And there are a lot of people that are working on this. And there are specific people who try to study the artificial intelligence. So as I mentioned before, like human is the most intelligent entity in the world, right? So people, they try to design or maybe build some system. They want to know or like kind of develop systems, implement systems that think and act like humans, right? Could be an intelligent agent, artificial intelligence, the kind of goal of artificial intelligence. So they try to learn how human beings think and maybe how they have some kind of cognitive functions, what kind of cognitive function they have. And they try to understand and model. And as I mentioned before, humans are the best. So if you learn about human, probably you can build some systems that act, I think, like humans, right? But what are the challenges? The challenges is like this. Humans often think and act in the way, but we don't consider intelligence. So, oh, there are some people doing some fool things, right? So they are not all the time intelligent. And the other thing is like detailed model of humans' mind, people's minds is not known yet, right? A lot of people, they try to understand and investigate these kind of humans' minds, how humans minds operate. So, and there is another the concept on the artificial intelligence. There's another the area. So these people, they don't want to think, they don't want to build some system that really think and act like human. It doesn't have to be human, but more like kind of, they want to build some system that's working rationally. Rationality is kind of the concept of ideal intelligence. So as I mentioned before, human, they don't do think and act all the time intelligent, right? Sometimes they are very doing some full decision, make some full decision or something like that. So, but rationality is as like kind of ideal of intelligence. So they don't consider whatever human think or do, but they do some really kind of the rational decision or make some rational decision. So think ideally. And synologism, I think you learned already about this in your maybe elementary schools or mid school or something like that. So in Greek, ancient Greek, they invented this kind of the tools, logic tool, inference tool, and they do a lot of things, derive some concepts or infer some concept rationally, something like that. But still, rationality is better than human behavior to define. It is more kind of objective. So you don't have to design a system, or maybe you don't have to investigate AI to look like human. There is one part, but more like kind of rationality. So something like this. And the goal of AI, there are like kind of the two goals, the scientifically and also engineering goals. The scientifically, what people do is they try to understand, analyze natural and artificial agents. So they want to know about want to know some principles about intelligent behaviors, and they want to test the hypothesis, and also try to build an experiment with some computational systems requiring the intelligence. So in the area of cognitive science, they do study about AI as well, but they're not like kind of building a real system, but they want to understand human and how they think, how they decide, how they act, and something like that. And they derive some kind of the theories or topics. But more in engineering area, they try to design and synthesize the intelligent artifacts. They want to design a real systems or something like that. And when we talk about AI, we could talk about, have to say the Turing machine. We have to mention the Turing machine. So we're gonna watch one video.
These have been vital considerations for the future of artificial intelligence. But British computer scientist Alan Turing decided to disregard all these questions in favor of a much simpler one. Can a computer talk like a human? This question led to an idea for measuring artificial intelligence that would famously come to be known as the Turing test. In the 1950 paper, Computing Machinery and Intelligence, Turing proposed the following game. A human judge has a text conversation with unseen players and evaluates their responses. To pass the test, a computer must be able to replace one of the players without substantially changing the results. In other words, a computer would be considered intelligent if its conversation couldn't be easily distinguished from a human's. Turing predicted that by the year 2000, machines with 100 megabytes of memory would be able to easily pass his test. But he may have jumped the gun. Even though today's computers have far more memory than that, few have succeeded. And those that have done well focused more on finding clever ways to fool judges than using overwhelming computing power. Though it was never subjected to a real test, the first program with some claim to success was called ELIZA. With only a fairly short and simple script, it managed to mislead many people by mimicking a psychologist, encouraging them to talk more and reflecting their own questions back at them. Another early script, Perry, took the opposite approach by imitating a paranoid schizophrenic who kept steering the conversation back to his own pre-programmed obsessions. Their success in fooling people highlighted one weakness of the test. Humans regularly attribute intelligence to a whole range of things that are not actually intelligent. Nonetheless, annual competitions like the Loebner Prize have made the test more formal, with judges knowing ahead of their conversation partners are machines. But while the quality has improved, many chatbot programmers have used similar strategies to ELIZA and Perry. 1997's winner, Catherine, could carry on amazingly focused and intelligent conversation, but mostly if the judge wanted to talk about Bill Clinton. And the more recent winner, Eugene Gustman, was given the persona of a 13-year-old Ukrainian boy, so judges interpreted its non sequiturs and awkward grammar as language and culture barriers. Meanwhile, other programs like Cleverbot have taken a different approach by statistically analyzing huge databases of real conversations to determine the best responses. Some also store memories of previous conversations in order to improve over time. But while Cleverbot's individual responses can sound incredibly human, its lack of a consistent personality and inability to deal with brand new topics are a dead giveaway. Who in Turing's day could have predicted that today's computers would be able to pilot spacecraft, perform delicate surgeries, and solve massive equations, but still struggle with the most basic small talk. Human language turns out to be an amazingly complex phenomenon that can't be captured by even the largest dictionary. Chatbots can be baffled by simple pauses like, or questions with no correct answer. And a simple conversational sentence like, I took the juice out of the fridge and gave it to him, but forgot to check the date, requires a wealth of underlying knowledge and intuition to parse. It turns out that simulating a human conversation takes more than just increasing memory and processing power. And as we get closer to Turing's goal, we may have to deal with all those big questions about consciousness after all.
동영상 소리가 안 들려요? 동영상 소리가 안 들렸어요? 진짜로? 제 자리에선 들렸는데. 이거 나중에 하여튼 좀, 들린 사람도 있어요? 들린 사람? 네. 다행이네요. 이게 혹시 안 들렸으면은 나중에 링크를 한번 보세요. 뭐 어차피 큰 내용은 아니고 튜링 테스트라고 하는 거를 이제 앨런 튜링이 처음에 제안을 하면서 이제 생각하는 기계에 대한 이제 논의가 시작이 됐죠. 아까 전에 우리 AI 인텔리전스에 대해서 뭔가 얘기해보자라고 할 때 좀 언급 안 된 거긴 하지만 랭귀지라고 하는 게 어떻게 보면은 또 코어 키 컴포넌트인 그러니까 인텔리전스의 키 컴포넌트 중에 하나죠. 랭귀지라고 하는 거. 그 랭귀지라고 하는 것들을 이제 튜링 테스트를 통해서 검증을 해본 거죠. 아까 전처럼. 근데 이제 튜링 테스트라고 하는 건 아까 전에 우리가 요 전 슬라이드에서 얘기했던 것처럼 어떤 시스템이 사람같이 생각하고 행동하는 관점에서의 어떤 인공지능에 대한 연구를 다루는 거였고, 레셔널리티 관점에서 다룬 건 아니었죠. 왜냐하면 가려진 상황에서 반대편에 있는 게 사람 같은가 아닌가를 찾아내는 거니까. 꼭 정확하게 답을 딱 가지고 안 있어도 이렇게 튜링 테스트 이제 테스트하는 예제들을 보면은 뭐 점점점 하기도 하고 뭔가 이렇게 하기도 하고 뭐 그런 이렇게 반응 같은 것들을 하기도 하는데 이제 그게 어떻게 보면 이제 사람같이 행동하는 거에 대한 반증이라고 볼 수 있는데 사실 이제 랭귀지라고 하는 게 어떻게 보면은 지금 이제 자연어 쪽 관련돼서 뭐 딥러닝이나 이런 것들에서 아주 이렇게 뭐 많이 발전을 하다 보니까 요즘에는 아주 뭐 재밌는 일들이 많이 발생하는데 뭐 전통적으로는 이제 랭귀지를 컨커하려고 AI 영역에서 이렇게 사람의 언어를 임플리멘트 하기 위해서 그 역량을 많은 노력들을 가져왔었어요. 그리고 이제 그것 중에 하나가 튜링 테스트였던 거고 슬라이드 그 외에도 사실 검색을 해보면은 자연어 쪽 그런 연구들이나 컴피티션 뭐 그런 것들이 되게 많아요. So in addition to the Turing test, recently there are a lot of like competitions work to implement the language capability. And one thing is Winograd schema. So here is an example of Winograd, he mentioned. The city councilman refused the demonstrator permit because they feared violence. And there is another sentence. The city councilman refused the demonstrators permit because they advocated violence. So there is a question: who fear violence? The first sentence, the second sentence, who advocated violence? Please give me your answers on the chatting window, please. So for the first question, who fear violence? 그 답변이 뭐죠? 첫 번째 그 문장에서. 이 영어 어렵나요? 그냥 아무거나 치면 되는데. Who fear violence? Please write your answer on the chat window. city councilman. There's one. Who fear? And what else? There is another other answers possible. Okay, so what about the second one? The city councilman refused the demonstrator a permit because they advocated violence. Who advocated violence? Who advocated violence? 누가? Demonstrators. 예, 다들 잘 쓰죠. 일단은 who 할 때 다른 단어 안 쓰고 city councilman이랑 그 다음에 뭐예요? 그 demonstrator라고 다들 답변을 잘 해줬어요. 첫 번째 거는 뭐 they fear violence라고 썼는데 그 they가 누군지를 여러분들 잘 알아낼 수 있죠. 그 다음에 두 번째 문장에서도 they advocated violence라고 했는데 they가 누구를 지칭하는지 이게 대명사에 대해서 사람은 되게 잘 알아내요. 그 전통적으로 그 자연어 처리에서 대부분 안 됐어요. 되게 안 됐어요. 근데 최근엔 되게 잘 되죠. 최근에는 되게 이제 대명사가 뭘 지칭하는지를 잘 알아내는 그게 이제 뭐 딥러닝 세상이 되다 보니까 또 되게 잘 되는데 원래는 잘 안 됐어요. So the property here for the Winograd scheme, people, you like you can easily disambiguating them, right? You know who they means, right? Indicates. But there is no simple grammatic or statistical test, but by your experience and also language capability, you instantly know the answer. And here, we in generally say this ability of human intelligence is common sense reasoning. There are a lot of like kind of competition and NLP problems relate to this common sense reasoning. So it's very important concepts, common sense. Because human, they learn a lot of knowledge. And out of this knowledge, you're not like kind of doing some inference. Instantly know about something, which is the common sense. So you don't apply some rules, some knowledge to this problem, but instantly you know the answers. That's the common sense reasoning. So how to implement this common sense reasoning into the system is kind of core topics of NLP area. I will kind of shortly mention, talk about the history of AI, but I believe a lot of you already know about this. So in one area, the psychology and the cognitive science, we try to understand the mind. And especially in the area of artificial intelligence, they try to implement some real systems. So there are some people mentioning symbolic reasoning and also try to design a general purpose computer, although they are not kind of working in practice. And as we already talked, Alan Turing, he proposed the Turing machines. And at the same time, there is another one who proposed the lambda calculus. And Church Turing series, something like that. It's kind of the Turing machines. So out of it, a lot of AI programs in practice they proposed. The Samuel, he built the checker programs. And there is another things, a lot of this and that. And one thing is like kind of in natural language understanding is kind of core the topics in AI. So they try to, a lot of people, they try to build some models that interpret human language. And Chet and IBM Watson, you already know this, right? And the other one, in AI area, another kind of core topic is the expert system. We're gonna mention shortly. So in this slide, you can roughly trace the history of AIs. The first stage, the second stage, and third stage. And between the stages, there are some kind of winters. but I don't think another winter is coming, because all the things nowadays working based on deep learning. So I think it's gonna be the fundamental and this basic components in our life. So in the first stage, a lot of people, they try to design some inference model. So they try to study and try to design some logic or reasoning system or something like that. So in that times, mostly the people in AI, they study symbols and symbolic learnings and planning or something like that. And the second part, the second stage, knowledge period, they try to implement some sort of like kind of practical systems. So at that period, a lot of like kind of expert systems in the medical area or some other area, they build some system and implement it in the real, but not that much successful. Yeah, it is because still AI was limited in some like kind of control environments. It's not working in the wild. There are a lot of exceptions and a lot of errors happens or something like it. And then during that time, still like kind of the technology developed. So nowadays we have a bunch of methods like kind of Bayesian network, supported vector machines, and neural network, and even we have a like kind of deep learning model, something like it. And a lot of success kind of happens, like kind of Deep Blue competing with the human champion and defeated him. And also there are a lot of like robots is coming out, and also AI assistants, like kind of the chatbots or the speech assistants or something like it. So nowadays, like kind of AI is prevail the old area, like. So we get into our small topics, and we just talk about maybe intelligent agents a little bit, maybe for 10 or 15 minutes. What is an intelligent agent? We just talk about the AI, right? But basically the AI, the goal is the synthesis. We have to implement a real working system, which is called computational agents, or sometimes we call intelligent agents. And this agent should act intelligently, otherwise meaningless, right? So for this, a lot of people, they study humans and human brain or something like that, but still what is the goal for the engineering perspective is implement the real working agent. And here the agent is something that acts in the environment. It has to act, right? It's not just like kind of thinking machine. It is kind of acting machine in the environment. So you have to, it has to get some inputs and doing some inference or thinking, and then it has to give answer to the environment or to the user and something like that. The answer is gonna be some knowledge or maybe some sort of like kind of physical actions, something like that. So, but the agents here, we are thinking not just a simple agent, but we are talking about intelligent agents. So agent has to act intelligently if it acts appropriately for goals and circumstances. So insect or maybe some animal or whatever, they act, right? They may be agents, but sometimes they are intelligent or sometimes it's not. But if you say it is intelligence, its actions should be for its goal and circumstance, right? And also it has to be flexible because environment and goal is changing all the times. But so it has to adapt to the changing environment. Otherwise, it's gonna be, sometimes it is very intelligent, but as times pass, it's gonna be no more intelligence, right? So it has to flexible and adaptable. For that, what it needs is like kind of learning capability. So you have to learn from experience. You have to kind of learn knowledge or learn new functions or something like it. So intelligent agent, it needs some learning capability. And also, this is the very practical the attribute. It may some kind of good choice, but it has to make some choice given a perceptual and computational limitation. Because all the time we have the resources not like kind of enough all the time, right? Sometimes it's limited in times, or sometimes it's limited in space. But still, if it is an intelligent agent, it has to make some good choice for these given the limitations. So here, we can roughly design the concept of agents. Here we have an agent, and here is the environment, right? So as I mentioned before, agent has to act in the environment. So it has to have some actions. So agents will be a simulation, sometimes in some environments or in the computer or whatever. And anyway, it has to action to the environment. And for this, what we have to have is like kind of agent has the ability, and also agent has goals and preference. But this goal and preference gonna be the users, right? It's not just agent itself. But sometimes, in general, like users goal and users preference, because agents do something for the users. And also it has a prior knowledge and stimuli and past experience. Let's get into a little bit more details. So ability here, which says the setup, the possible actions it can perform. And goal is what it wants, what it desire or value or something like that. In general, like kind of user's goal, right? And user's preference. And prior knowledge here is like kind of is something being known, but it's not from the experience. So when you design some intelligent agents, you can just write down some knowledge, right? It's not like kind of learn from experience. And since it is walking in the world, walking in the environment, it has a stimuli, right? So it has a history of stimuli. Sometimes current stimuli is kind of input, what it received from the environments at the moment. And past experience is the history of such stimuli in the past. So here we're gonna talk a little bit about the agents. So here are a lot of things listed: the soccer playing robots and log, and machine translator or thermostat, or dog and cat, car, or something like that. So do you think are these things an agent or not? So let's talk about the soccer playing robot. Is it an agent or not? Do you think it's an agent? Yeah. Oh, why? Oh yes. There is no one say no. Okay. Tell me why. Why do you think it's agent? Oh yeah, it's very important things he mentions. So we just talk about, hold on. So this structure, right? So you have to kind of consider, this is kind of definition of agents. Agent has to have ability, goal, prior knowledge, stimuli, and past experience and actions, right? So based on these definitions, maybe the soccer playing robot, it has ability, right? And goal, prior knowledge, and stimuli, past experience, and also actions, right? And what about log? It doesn't have any action to the environment, right? So it could be a agent. Machine translator, thermostat, or dog, or whatever. Okay. Are these things an intelligent agent or not? Let's talk about thermostat, as I mentioned earlier. Do you think thermostat is an agent or not? Here, thermostat agent. Is this agent or not? Agent. Agent. Okay. Okay. And do you think it's a intelligent agent or not? No. What are the people? Is there anyone who want to say yes? Or intelligent? Oh, there are two people saying no and one student saying yes. Intelligent. Oh, what else? Junior, what do you think?
저는 맞다고 생각합니다.
맞다고 생각한다고?
네.
오케이. 왜 맞다고 생각하는지 얘기 좀 해줘봐.
무언가 사람에게 기능을 해줄 수 있기 때문에.
무언가 사람에게 기능을 해줄 수 있다라고 하는 건 에이전트인데.
그래서 에이전트가 맞다고 생각합니다.
아, 인텔리전 에이전트가 맞냐니까. 화면을 켜놓고 집중을 안 하고 있구나. So, Wahid, why do you think is intelligent?
Yes, Professor, because thermostat change is temperature based on the environment. So if room temperature set 23, so this machine is collecting data from this environment, and when it reaches its target temperature, then it switch on the heating or switch off the heating. So it's kind of intelligent.
Okay. So maybe what just Wahid mentioned, I think it could be, we can say is the agent, right? Agent has a logic. So if you give some input, and it will give some output. But when you say intelligent, could be very complicated. Sometimes it look like intelligent, or maybe sometimes it's not. If it is intelligent, you don't have to change that much, right? But many times you have to turn it on and off. You have to control the temperature or something like that.
Yes, Professor.
Yeah, I think 10 years ago or something like that, there are thermostats coming, is kind of AI thermostats coming out in the market. And at that time I was in the United States, and a lot of people, they really want to install that thermostat at the room. And what it does is like kind of you change several times for about a week. and then it learns from the experience. So later it automatically changes the temperature in the room, something like that. But then we may say it's intelligent. So definition of intelligence is quite not easy, but it's very up to like kind of its functions, or maybe up to the definition of intelligence, kind of how broad it is or how specific or not. And there are a lot of like kind of agents we can say, like organization, like Microsoft, we say agent, maybe government of Canada, agent, CS department, AI department is kind of organization, and in general we say is agent, right? And what about the people, teacher, physicians, engineer, researcher? We can say they are agents, right? They get some inputs and output, action to the environment. A lot of kind of computer or something, user interface, advising system. We can say that all of these are intelligent. No, agent. But some are intelligent, some are not. Animal could be or not. Maybe book, sentence, word, letter. It's very hard to say it's an agent, right? It's not like kind of, although book kind of influence the world, the people, but still is not like kind of directly give some input or no action to the environment. So it's very hard to say that. So giving, talking about some example, we just learn a little bit more about these concepts. So we have autonomous vehicle. We can say its ability is steer, accelerate, and brake, right? It's kind of the general, the car functions. So it has ability. And what about the goal? It has to drive safely, right? And also it has to get to the destination. And at the same time, time limits, right? It is too slow or too light. You don't want to take that. Maybe it also has some prior knowledge. So map data, and it also has to learn what sign means, right? Blue, if you see blues, it may go, or red, it may have to stop, right? And also, it has to know what to stop for. If there's an obstacle, or maybe people's coming out to the road, and it has to stop, right? So those kind of knowledge has to be encoded in advance to deploy this the vehicle. So we say this stops to prior knowledge. And what about the stimuli? It may have some vision sensor or radar or whatever, or GPS or voice commands or something like that. So you may get some information from the world, the environment, and from the road. At the same time, maybe get some information from the driver, the user, right? I want to go there. I want to go this route. And maybe, oh yeah, I want to have a safe driving. Or maybe I'm very late, so you have to barricade or something like that. So it's kind of the preference, right? And past experience, how braking or steering affect direction or speed. So maybe road conditions or environment is not like kind of all the time same. It changes slowly, or maybe the situation is different by place to place. So from our experience, we can learn that, oh, if you brake this amount, it affects the speed this amount. And maybe if you turn the steering wheel like this, maybe actual direction, driving direction change like this in this condition or something like that. So you have to learn that from the past experience. Here we can say the thermostat for heater, maybe turn heater on and off. It's going to be a ability, and the goal going to be a comfortable temperature, right? But at the same time, you have to save fuel and save money. It is comfortable, but you spend a lot of money. You don't want that, right? And prior knowledge, what is the 24-hour cycle, or what is the weekend or something like, you have to learn that. During weekend, these people are all the time at home. gonna be a kind of past experience, but you have to understand the time, the weekends, and 24-hour cycle, something like that. And stimuli gonna be the temperature, and also the set temperature gonna be kind of relate to the goal, but anyway, it's gonna be a user input, and who is in home. If there is no home, it doesn't have to kind of turn on the heater, right? And outside temperature or something like indoor temperature or something like it. And based on this stimuli and apply the knowledge, and you can fulfill the goals. And here, the experience is like when people come and go and who likes that temperature or not. So this is gonna be a good example. So I hope you to write down some example by your own, but we run out of time, so we're gonna skip this. Okay, so for today, we just cover some introductory materials on AI and agents. And on Thursday, we're gonna go more details of the characteristic attribute of intelligent agents and how we can design such agents or something like it. Yeah. Okay, I'm gonna. So please turn on the camera and have any questions or comments? No questions? Okay, is everything okay? So we're gonna try this Zoom working better for next time. I'm gonna try this and that because today look like we have a lag, and yeah, the slide, the recognition is not that good enough. So we'll see how we can do. And if you don't have any questions, so we can end today's class here. And whatever you have any questions, just send me an email. So maybe just leave some comments to the GEL, the website. Okay? Okay. So see you on Thursday.
감사합니다.
목요일에 봅시다.